Hello everyone, welcome to another video. In the last video, we have seen how a test engineer can define a test plan and all the test cases related to the software requirement, and also prepare some coverage between software requirement and the test case. Okay, so in the process, usually once the test plan is confirmed and defined, the next step is to prepare the setup of testing. Okay, so if you are in the lab, you should prepare all the tools that you will need to do your testing. For example, you can prepare all the harness, your power supply, some tools like oscilloscope, and other tools. Also, you can prepare some software tools like the tool that you can use to flash your ECU, and also prepare your configuration in Canoe if you use Vector Canoe as a tool. Also prepare your test cases in your Vector Vita Studio, for example, if you use it as a tool to define your automatic testing. Okay, so this is in general. In our case, we will simulate our ECU under test. So we will just focalize to prepare the setup testing environment in a simulated environment. Okay, and also we will need the two principal tools, Vector Vita Studio and Canoe. Okay, so let's start. As I told you before, this video will focalize on the testing environment setup for the ECU doors as an example of project. So we will keep the same example of project. So here the doors ECU represent our system under test, or SUT, and it communicates with other ECUs throughout the CAN bus, which is the main communication network used in our example of project. Okay. So in order to test the doors ECU in a controlled environment, we simulate the behavior, simulated doors ECU, that normally interact with it. So the behavior that normally define our ECU, doors ECU. Okay. This simulation is performed using Canoe as a tool. This is an overview of your Canoe, which allows us to reproduce the vehicle network behavior. So our vehicle network is the CAN bus, is the CAN. Okay, so we will use Canoe to simulate our ECU under test. This is the first thing. And also, we will simulate engine ECU. We will simulate it in Canoe. And this ECU provides information related to the engine status, like ignition state or vehicle operation conditions, like velocity of the car, for example. The signals are important because some doors functionalities depend on the engine state. Okay, so some doors functionality can be dependent directly to some information that can come from engine ECU around our CAN bus. Okay, and then we simulate also the console ECU in Canoe, which represents commands coming from the vehicle interface. For example, a door lock or lock request triggered by the driver. Okay, so the driver can request door lock or unlock by pressing some button, um, by interacting with the vehicle directly. And the ECU, the console ECU can send some request to the doors ECU, and then doors ECU can answer by opening or by unlocking or locking states. Okay. So both ECU's simulations are controlled using system variables. As you see here, engine ECU and console ECU are controlled by using some system variables, which allows us to manage the rest bus simulation and dynamically control the test scenarios. Okay, we will see this in details in our next videos. Okay. We have also TFS, test framework system. It's implemented using VTest Studio, and it manages the automated execution of all the test cases, and it sends stimuli to the doors ECU, via the CAN bus, of course. Monitors also the ECU response and compare them with the expected result defined in the test plan, in our test plan. Okay. So here you see the two interactions between the CAN bus and VTest Studio, our test framework system. So the TFS can check the reaction of the doors ECU, and also it can control the rest of bus using some system variables, using the system variable of engine ECU and console ECU. Okay, I've seen Cano and Vector VTest Studio. VTest Studio, to implement the automated test case, Cano to give a simulation of our ECUs that we will need in our testing task. Okay, thank you for watching. See you in the next video.